All right, I think we can get started. Okay, so and welcome to this session on program comprehension. So we have papers in this session. I am Prajesh. I'll be the session chair for this session. So, uh, so I welcome all of you to this session and papers. So I'm sure all of you are aware of how it works. So uh, each presenter will have 5 minutes to present their paper. Uh, Strict on time because we want to spend enough time on discussions as well. So after 5 minutes, I will give you a small warning to wrap up. And so we will, and so the five authors will present their papers one after the other. And then we will have a time of discussions and question and answers. While if you have any questions, you can type it on the chat as well. So at any time during the presentation. So we have Pooja who will be presenting her journal first submission. What do class comments tell us? An investigation of comment evolution and practices. You, Pooja.
Okay. Do you see my screen?
Yes, yes, Pooja.
Okay. Hello, everyone. My name is Pooja Rani, and welcome to our journal first paper talk. It's about what do class comment tell us, an investigation of comment evaluation and practices in Faro Small Talk. We have done this work together with the Zurich University of Applied Science and University of Auckland. So, what are class comments? A comment, as you know, programmer readable explanation or annotation in the source code of a program. Developers generally write comments to explain the rationale behind their code or to present the overview of the code. Now, various studies have done work on with code comments, and they found out that code comments assist developers in program comprehension and maintenance tasks. However, not all languages have the same style of writing comments. They use different notations to write code comment. For example, here is an example of Smalltalk class comment, which if you observe, it's quite different from Java. If we look a bit deeply into it, the comments are separated from code and written in a specific window. Even in terms of style, also they are very different. For example, the first line is it's written using first person pronoun and it indicates the intent or summary of the class. Now here the developer also wrote an example on how to use this particular class, and in addition to the high level information, they also write implementation detail. Since one of the thing in Smalltalk is that class comments are a main source of documentation. And so developers embed different kind of information. However, there are now all these unique things also makes challenges. For example, since class comments are a main source of documentation, developer different type of information in them. There are no strict comment convention such as tags in Smalltalk, and also there are not enough quality assessment tools. And to use basically the previous technique from Java or Python into such an environment, it's a non-trivial task and it requires a lot of empirical knowledge. So in this study, we studied Smalltalk class from three different perspectives. What are the commenting trend? How developers are changing comment with respect to code or without code? What information developers are writing inside comments? And when they write comments, they follow some kind of template or style guideline in writing them. So in Smalltalk, we conducted our study on the Faro environment. So it's a live programming environment for Smalltalk software system. It's like an IDE, like Eclipse or IntelliJ. Now this IDE is written in Smalltalk. This software system first in 2008. So we studied 11 years of history to analyze Smalltalk class comment. In commenting trend, what we found is that 50% of changes in class comments were related to code changes. For example, somebody added method and that caused a change in class comment. However, in this study, we could also see that 50% of other changes were unrelated to code changes, which are also very important. Then we move to our perspective, seeing what information developers are writing. And what I mean by information is like intent, example, implementation detail. And this type of information segregation has been already done in Java and Python. However, for Smalltalk, there is just no common taxonomy. So we wanted to see that is there some other kind of information that is available there, or what's the spectrum basically. And what we found is that class comments in Smalltalk, they contain 23 types of information, and the intensity of the information varies. So we could see that there are some high level overview detail. In addition, we also found instances of conversation exchange, which was a bit surprising for us, that even the comments are a platform to exchange ideas and recommendations and observations. Then we wanted to see that whatever this information is written, do they follow some kind of style? Now in Smalltalk, when developer you go to write a class comment, the environment provide a default comment template. It basically tells you how you should write comment, class comment. It tells you that you should write a summary, you should write responsibilities. So it follows the CRC based design. So in our study, we measured that whether comments follow the template or not. And just to highlight one point, that we found that these information types, the frequent information types, were actually inspired from template. So whatever template is telling developers to write, it's followed quite much. Also, there are other type of information also which developers write, but at least the one template suggested were written more often than other. So as a main takeaway, we found that developers embed different type of information in class comments, and if we want to help developers, then we can extract them automatically and help them in various tasks. So the ultimate goal of automatically assessing comment is still far away, and we have various future directions, finding which information is important, how they can support developer, and how to extract them automatically. And the paper is already available. Replication package is available on GitHub. Thank you.
Thank you, Pooja. Thank you for that wonderful talk. Yes, so let's move on to this too is a journal first paper. It's titled An Ensemble Approach for Annotating Source Code Identifiers with Part of Speech Tags. Christian Newman will be.
All right. Can you all see this?
Yes.
Yes? Okay, good. All right, so hello, my name is Christian Newman, the head researcher at the Source Code Analysis and Natural Language Laboratory. Today, we'll be discussing part of speech tagging tool and its importance to identifier research. So my lab is Scannel. Scannel is interested in the latent connection between source code behavior and the natural language elements used to describe that behavior. We have a number of talented individuals working as part of the lab and plenty of interesting research and tools that can help you pursue topics similar to what we're working on. Please visit our webpage if you'd like some more information. So identifier naming is a largely unresolved research area. We don't really have any general ways to measure identifier name quality, only heuristics. And there is very little understanding of how different characteristics of identifiers influence comprehension of people and machines that read code, like artificial intelligences. Identifiers also follow a different phrasal structure than normal human languages, meaning that many off-the-shelf NLP techniques don't necessarily work on identifiers, and almost certainly won't work as well as they do on the data sets that they were trained for. So using and creating natural language techniques for this problem is important. And identifiers are how developers come to understand the code that they're reading, and they must read and comprehend code before they can do anything else as part of their development, whether that's adding features or fixing bugs. Anything, they have to read the code first. So identifiers are how automated techniques analyze or identifiers are also how automated techniques analyze and understand code. Can we trust techniques when the underlying information that they are using can vary in quality and we cannot measure that quality easily? If a technique or a research study relies on identifier name information, can it be trusted if the identifiers it relies on may vary in quality between systems and we can't measure or control for that quality? Because the difficulty in measuring identifier name quality and our incomplete understanding of how they influence comprehension tools, including for humans and AI, they represent a threat to validity for any tool or research that uses them. So the part-of-speech tagger is an example of a tool built for this specific context of identifiers in source code. And a lot of Scannel tools are built from this perspective. The motivation for our part-of-speech tagger was from the perspective of our lab, was to support grammar pattern analysis of identifier names. Grammar patterns allow or help us measure, express, and comprehend identifier meaning and characteristics using part-of-speech tag sequences. They can be leveraged by both humans and automated techniques. So here's an example of a grammar pattern right here, but we're not going to spend too much time on this because we're going to kind of see a larger example here in a moment. So this was the original paper for the grammar patterns research. And from this paper, what we did was we created this, what we kind of call the identifier naming structure catalog that kind of goes through different types of identifier naming structures and talks a little bit about how these various naming structures are used to connect natural language stuff to the behavior of the code. And so we actually found several different types of patterns that developers commonly use to describe things like event handling or certain different types of functions or set operations, that kind of stuff. So we found a lot of neat stuff that you can use these to analyze. So this kind of brings us to the tagger here. So what we did was we took a number of part-of-speech taggers that have been created in the past. This is Stanford Tagger, SWUM, and Posse. And we ensembled them together using the data from our grammar patterns paper and a decision tree machine learning approach to help increase the accuracy. Because if we want to be able to use grammar patterns to study this kind of stuff, then we needed a good part-of-speech tagger to actually identify these patterns accurately. So what we ended up getting was an increase in accuracy of about 17% at the identifier level. So this is the best approach was around 55%. We increased that to around 75%. And 86% at the word level if you're looking at just individual correct words. So we did quite a bit of improvement by creating this approach. Yeah, so if you want more information, please visit our webpage. We also have the tool publicly available. The data set is also publicly available if you go to the ensemble tagger link here. And also the identifier naming structure catalog, which is the thing that we use this tagger for a lot, is also here. If you have any questions, feel free to send us emails. We always love hearing from people. Thank you.
Okay, thank you, Christian. Thank you for speaking tonight. It was an excellent presentation. Now we'll be moving on to the third paper. This is also a journal first paper. Why my code summarization of work? Improving code summarization with comment category prediction. We have Chuyan Chen who will be presenting.
Okay, thank you, Prajesh. Hello, everyone. I'm Chu Yanchen from Zhejiang University, and I'm a PhD candidate in Zhejiang. And I'm very glad to be at ICSI venue to give my presentation. And my topic is why my code summarization model doesn't work, code comment improvement with category prediction. And our presentation consists of 6 parts. And first of all, to introduce the background, let me ask the question: what are the 2 things that developers hate the most? The first is comment my code, and the second is people don't comment their code. So for this, it's a big problem. So for this, researchers propose comment generation, or you can also say it code summarization. And is given a piece of code like this, Of course, this is a function level code, and the technique can automatically generate the summaries for it. And however, there are many types of code comments. In general, current approaches often capture information inside the code, but there are also many information outside the code. So we have a problem that is, can we generate all kinds of code comments? And based on this question, we propose two research questions. First is, how do different comment categories impact the code summarization performance? The second research question is, how can we improve the code summarization performance using different comment categories? And this is our research overview. The blue part is our empirical study. In this part, we manually label some data and we give some findings. And in the red part, we can say we propose our approach. That is a composite model to take advantages of different models. And first of all, in the empirical study, we divide current comments into 6 categories. That is what, why, how to use, how it is done, property, and others. This category is based on the standard by Zhai et al. And we manually classify 20,000 code comment pairs. And this process is, and the details can be found in these tables. This process is labor intensive. On average, we label 57 pairs every hour. And based on this labeled data, we choose several state-of-the-art approaches. And our experimental results are in this huge table. But we don't have to go into the details because of the time limitation. And in summary, we have three main findings. The first is no model can perform well on the Y category. That means there are many information outside the code, and if you don't know this information, the model cannot perform so well. However, NNGene is a retrieval-based approach. It captures the information from similar code. It can capture some outside information from the code. So it has a relatively better performance. And the second, no model can perform well on the property category, and each model has advantages in different categories. So we have a question, that is, can we combine different models to take advantage of different approaches? And our approach, so we propose our approach that is a composite model. The core idea is comment category prediction. That is assigning the appropriate model according to the predicted category. That is, for example, given a piece of code, if you know what kind of code comment, what category of code comment it should be, and we can choose the according models. For example, as we know, code to sequence based on our experience, it performs well in a how to use. So if we know the given piece of code has the category of how to use, we can choose code to sequence. And so as for the DeepCom, as a result, our experiments use the random forest as the selector based on the priori experiments. And as we know, the performance of which model performs better it comes with priori knowledge. So we constructed a new test data set, and it don't have such a priori knowledge. And the result shows that our composite model outperforms all benchmarks. And it demonstrated that using comment classification, or you can say comment category prediction, it can improve the code summarization performance. As a conclusion, in summary, our core question is, are all kinds of code suitable for comment generation? And for this question, we divide comments into 6 general categories. Of course, we can divide it into more detailed categories. And then we label in 20,000 pairs. And then we propose the comment category prediction. That is our core task. And we use this task to propose our composite model, and it outperforms the state-of-the-art approaches. And this is okay. Of course, there are many more details, So for more details, please refer to our paper at my website. And you can also get the source code on my GitHub. And also you can, if you have any questions, we can discuss later, or you can contact me with this email. And that's all. Thank you.
Thank you, Chuyan. Thank you. Thank
Okay,
you. Presentation. Okay, we move on to the next paper. State trans code summarization with efficient tree structured attention. Zay Tang will be presenting the paper. Yeah, over to you, Zay Tang. You're on mute. You can unmute.
Can you hear me?
Yes, yes.
Okay. Hi, everyone. My name is Zetang from Nanjing University. Today, I will be presenting our paper entitled AST Trends Code Summarization with Efficient Tree Structured Attention. Our work focuses on code summarization task. This task aims to description for source code, and many works use the AST of source code for summary. However, ASTs are much larger than the source code. For example, in the figure below, the 11 lines code has an AST with more than 30 nodes. So our purpose of this work is to reduce computational complexity for encoding AST in code summary task. To do this, we design a new method to encode AST. As the children nodes of AST are ordered, we view the tree in two parts. One is the ancestor view, and the other one is the sibling view. We treat the relation between nodes as the relative positions and use different attention heads for different views. The attention computation was optimized by GDC algorithm and then concat with each other. The overview of our method is shown in this figure. We use the transformer architecture, and the input of the encoder is the pre-order traversal sequence of AST, and the relative positions are replaced with the ancestor and the sibling relationship. Next, I will talk about how we optimize our computation. Our idea is quite simple. If the distance between nodes beyond a threshold, in this work, the threshold is set to the max relative distance. We treat them as no related nodes. Or in other words, we do not need to compute the attention scores for these nodes. So actually, we convert the attention score matrix from a full matrix to a sparse matrix with many places no need to compute. Then we design an algorithm called GDC to compute the sparse matrix more quickly. And the idea of GDC algorithm is quite simple. We split the matrix into sub-matrices with the same value, and we proved that the non-zero elements in each sub-matrix are no more than n-1. And then we can use the similar way as in sparse attention mechanism, use dot production to replace the matrix production, so the complexity can be reduced to linear. We analyzed the complexity for 5 implementations. The mask implementation is equal to the standard transformer. GDC and GC are 2 implementations we proposed. Though the loop implementation has the lowest complexity, it cannot be computed in parallel. The mask implementation grows quadratically with the AST size. The complexity of GDC grows linearly with the AST size and has the fastest speed and with the lowest memory cost in GPU. We do our experiments on 2 datasets. The results show that AST trends outperforms all the baselines. Also, we do a population study to verify the two relations. As can be seen, the performance both dropped without ancestor or sibling relation. So it proves that the ancestor and the sibling relations are both useful. Thanks.
All right. Thank you, Zay. Thank you for your talk. All right. So let's move on to the final paper session. We have new who will be presenting the paper titled SPT4 Sequence to Sequence Representation of source code.
Okay, thank you. Can you see my slide?
Yes, yes, Chandra. Yes.
Oh, thank you. Hello, everyone. I'm Chang'an Niu, a PhD student from Nanjing University. Today, I'm going to present our paper, SPT code, sequence-to-sequence pre-training for learning source code representations. In recent years, by automatically generating labels from the input text, self-supervised pre-training has achieved a big success in the field of natural language processing, resulting in many landmark models like BERT and GPT. Inspired by the success of pre-trained models in NLP, a number of pre-trained models of source code have been proposed and applied to a variety of software engineering tasks, and with notable successes. However, there still exist some issues. First of all, many models focus on pre-training the encoder part of transformer, where the decoder is left out. Second, the code structure, such as AST, is largely missing. Last but not least, when a model uses the natural language in the input, they are using the function-level documentation of the code. This indicates the available of documentation is assumed, which in fact is not always available and not label-free. To address these issues, in our paper, we firstly propose to pre-train both encoder and decoder in a sequence-to-sequence framework. Then, we introduce a simplified and linearized version of ASTs. And last, we propose an approach to extract natural language from source code only, which called names and is also label-free. Our model is based on transformer, and our input contains three parts. The first part is the sequence of code tokens, and for the second part, we use XSBT at the expression level. XSBT is an improved version of SBT. Expression level means that we further ignore the terminal nodes and their direct parents. The last input is natural language, which is the concatenation of the method name and the invocations in the body. As for the pre-training task, our first task is code AST prediction. It aims to make the model learn the alignment of codes and ASTs. The AST input part of a training instance has a half probability of being from another training instance, and we make the model to distinguish whether it is happened. The second task is mask. In this task, a half-length sequence in the input is replaced by a mask symbol. Then the model is asked to recover this mask sequence. The last one is method name generation. It makes the model to generate the method name given its body. It trains the model to learn the functionality of code without requiring its documentation. As for experiment, our pre-training dataset is code search.net, and we adopt 5 downstream tasks to evaluate our model, including 4 sequence-to-sequence tasks and 1 understanding task. Baselines include task-specific models and pre-trained models of source code. This is our evaluation result on code summarization and code completion, and the result on the remaining tasks. It can be seen that our model achieved the state-of-art performance on sequence-to-sequence tasks, and also achieves performance comparable to the current state-of-art on understanding tasks. Thanks for listening. More details can be found in our paper, and we also have made our artifacts available on GitHub.
Thank you, Chandan. Thank you for
Thank you.
your
Thank you.
Thank you. All right. So good. We have around half an hour for discussion. So yeah, so I would encourage all those who are there in this session, the audience, to ask questions. You can either unmute and speak, uh, or you can type in the chat. So please feel free to ask questions to the presenters. So we have one chat from Christian, who's asking Chuyan
Yeah.
about what kind of comments are there in the other category. So
Okay. In the other category, first of all, the comments in our experiments, the comments are all summary. That is the first sentence of the function level code, and the others meaning are some unspecific natural language. For example, to do, they just say and write a to do, or some jokes or some other things that cannot be specified to any categories. Yeah.
follow up.
Yeah, as a quick follow-up.
I have a follow-up question on your paper. You propose different models, different kind of models. Maybe these models that basically having all these models in production would make sense.
So
Or
sorry,
is it
your voice has delay in my side, at my side.
So the question is, you propose different kind of models for different kind of comments.
Yeah.
How realistic is in the industry world where just for this bunch of lines we have 5 models?
Yeah.
And how heavy these models are?
Let me repeat your question. That is, in my
I
understanding,
will just write also I will also write in the chat.
Oh, sorry, I can't see the chat. My chat cannot refresh on time. I think your question is how realistic it is for the models to be in practice. Is it?
Yes, yes.
I think our priori knowledge can be a reference, but for some more detailed categories, this knowledge maybe not very practical enough. But if we can collect several, not so much data, but maybe hundreds of data for some specific categories. For example, not so general. For example, for a tool category, it maybe has some input output category comments, and with this knowledge, the knowledge of which models performs better, we can make it more practical. That's all.
But do you have a threshold on how many comments you need at least in one category? Have you figured this out? Like, let's say if in a category I have only 20 comments, would the model still work? Or you have to adjust the model parameters according to the size or data points?
Sorry.
So let's say the models generally need, these are data hungry models. They need a lot of data.
Yeah.
It's a category which have only very few comments in that category. Do you need to adjust your model parameters, or you haven't figured out the threshold yet?
I think your question is for the situations of very few data, and
Yes.
if our model can work. I think it it doesn't have any impact because we have a trained model and we just fine tune the model and it can work in some
But
situations.
when you were training, you had like a balanced data set. That's very hard to believe for me.
Um, yes, it can be. It's an interesting problem. It's an interesting question. But if we should improve the performance, I think um, more detailed categories can be considered. Yes, and because our main the main goal of this work is to demonstrate that we cannot consider the code summarization as one general purpose, but we should consider different categories. But there are many other approaches to achieve. For example, some pre-trained model, we didn't use it. And in our future work, we may consider using such kind of pre-trained model. And in it may be a question of some few short or zero short problem, but in this work, we didn't consider it. Yes.
Thank you.
Thank you, Chuyan. Christian, you had a follow-up question. Yeah, you can ask.
I should have actually written it down. It slipped my mind. I think it was related to the other because I think you referred to some other finer grain categories, or were they other categories outside of the ones that you presented in the paper? So you said that I think you said something about you could find some finer grain comments or finer grain categories for your comments. Would there be so do you think that that would be a good future direction for this work, finding finer grain comments? Like, is there a good, is there a motivation for doing that, or do you think that that would be that the comment level that you're at right now is appropriate?
Yes, for some specific categories, it surely can works better. For some finer granularity or finer categories. For example, we noticed a kind of work that they generate code comments, not code comments. They generate user notice for smart contract code, and this can be more useful than the general purpose categories. Yes, it can be a very promising future work because the code comments you can put anything into the code comments. Yes.
Thank you.
Okay, thank you, Christian and Julian. Do you have any other question? You can unmute and speak. Okay, so Chuyan, I also maybe even can answer this as well. So, Pooja, you presented some categories of comments in small talk, and Chuyan also, do you see some similarities in the type of categories in small talk and what Chuyan presented? Are there differences? Comment on that.
Yeah, actually there are some because the kind of earlier work about how to it's from a very popular paper, and I also use it as an inspiration to see the semantics of code. And although in my case I just focused on very detailed category on the sentence level because we wanted to segregate every single sentence, and that's why you could see that there is a wide range of spectrum on the categories, while in their work they focused on what is this, how, what category, how category, which are like, let's say, more abstract level. But there are similarities, and I would say these are positive similarities that we are just trying to go more specific. If we know the models for what and how, we can also adjust them to specific categories, then afterwards I think that's a nice future work.
Right, right. All right, got it. Okay. Chu, do you have any comments? Can you hear me?
Sorry, I just reopening the page because I
All
cannot
right.
refresh. Yeah.
No, no, I was just asking Pooja about, she has some categories in her paper, and I was just asking her, were there similarity the categories of comments which you found out, you know? So,
Okay, I hear the question is the similarity of my the categories in my work and the categories of Pujarani. Is this question?
yes, yes, yes,
Oh,
yes,
okay. Yes, yes. At the first of our work, I think the categories, the taxonomy, the building of taxonomy is very hard, and we try we tried many approaches to build this taxonomy, and uh, and we find that it can be very easily to go into many detailed categories. For example, thousands of or hundreds of detailed categories, and and then we find the CPC, and that is referenced in our paper, and they give what, why, how to use, how to done, and I find this kind of categories can be more general purposed, and since the goal of our work is to demonstrate that if you divide categories into several categories, you divide the comments into several categories, you can improve the performance, and you can improve the code summarization performance, and uh, uh, that is our purpose. So we don't dive into the many detailed categories. And for a more, I think for a more useful category or for a more useful taxonomy constructing, I think we should know uh, why we should know the scenario of a specific usage of the comment. And for example, for a legacy system, maybe the developers they don't want to know how it is done, but if they maybe want to know more about how to use the code, so the comment should consider more this kind of categories. And so we just um, encourage you to take comments into different categories. That's all.
right. Thank you, Chuyan. Thank you. Others, do you have any questions? Or presenters, do you have the others, other presenters? Okay. Okay. So I have a question which I was thinking of maybe to. So I was just wondering how this the resources which you have on the GitHub and all of that, can it be used by maybe maybe to teach type the importance of appropriately naming identifiers, or even can it be a good resource for junior developers also? So this was what I was thinking about.
Yeah, so the catalog is actually directly meant to support education and actually categorizing different types of identifiers that we see. So the idea behind creating it was that we actually don't really know very much about what types of identifiers there are out there. Before the grammar patterns paper, there was only one or two papers I know of that even looked at kind of the grammar patterns of identifiers, and those papers were very limited in the numbers that they were looking at. And so what we found, like I showed earlier, was that there are a lot of different types of kind of high-level categories that developers use to name identifiers that have different purposes within the code. And so yeah, so it can really be used as and I have used them in our courses as an educational resource to kind of give students hints as to how they should be structuring identifiers that have different purposes in their system. And we're also working on tools that can recommend the patterns that we were kind of looking at in that catalog to developers as they're typing, to help them kind of get an idea of what sorts of identifiers they should be using in different locations, so that we can help, formalize and increase the quality of identifiers, just kind of generally speaking. It actually turns out that even helping developers stay consistent in the ways that they're naming identifiers can really help, increase their ability to comprehend what's going on.
Yeah, that's an interesting. That's very interesting, and I think that will also help in other tasks like code summarization, comment generation, and all of those things as well, right? Like we are able to give good identifiers that can help in many other tasks.
Yeah. So one thing that it remains to be proven. So we are working on some stuff to kind of show this, but yeah, like techniques that leverage identifiers, so code search, summarization, anything that uses the identifier could see some benefit from, first of all, understanding these patterns, and then second of all, if developers actually follow the patterns consistently, like if we can get to a world where people actually like are more kind of have a more formal method for providing names, and it could just generally improve anything that's reading the code, because they can predict the structure at that point. You won't get such a wild difference in the quality between different systems. Yeah.
Right. Thanks, Christian. Very interesting. All right. Okay, so we have a question. The AST trans paper. Zay, if you're there. Shangwen, do you want to unmute and speak? Okay, so the question of Zay is, your approach aims at improving the efficiency. So in your opinion, what is the main reason that leads to improvement? Zay, can you hear me? Mm.
Sorry, I don't hear clear.
No problem. Yeah, so the question is, your approach aims at improving the. So in your opinion, what is the main reason that effectiveness improvement?
So the question is, we prove the complexity is be proved. The performance were dropped. I don't understand.
So the question is there in the chat. Are you able to see the chat?
Okay, I will refresh.
Yeah. Or if Shangwen Wang, if you want
Hello,
to unmute and speak.
can you hear me?
Okay, I know the problem.
Yeah, Shengwen is here. So Shengwen, you can ask the question.
Yeah, my question is, I remember that in your presentation, you emphasized that encoding the whole sequence of encoding the whole AST is very
computational consumption. So you propose an efficient way. So my question is, will it decrease the effectiveness? Because I think by doing so, it will lose some information. But I also see your approach achieve some improvement with respect to the effectiveness. So I want to understand why, in your opinion.
Okay, that's a good question. So in our paper, we proved that the relative distance, if you set the relationship distance longer, the performance will be improved. But if you set it more larger, the performance will be still the same, still the same. And the you said if we ignore the relations beyond the distance, the performance will be dropped. Actually, the idea comes from the NIPS 2019 novel position encodings to enable tree-based transformers. In their paper, they I sent it in the chat. In their paper, they create a stack-like tree position encoding, and the idea behind it is for two far away nodes, the relations did not impact the performance.
Okay, thank you.
Yes, thank you.
Yeah, maybe we can discuss later. Thanks for the answer.
Okay.
I have a following question.
Yeah.
Hello. Yeah. I wonder what is the efficiency. The efficiency it is lies in the training phase or in the inference phase. That means I see your paper. It says that the size of AST can be very efficiency, but the training time will it be reduced, or it can be very quick to inference code summarization.
The training time will be reduced. Yeah.
Yeah, and so can it be very quick to generate I mean, after you train the model, when you put it in practice, and can it be very quick?
Yes, the time will also be reduced as the
and if
as
there are...
the features. Okay. The features the model need is can be the features the model needs can be saved as a list. One list stores the start nodes, and the other list stores the end nodes. And we design an algorithm to translate the start nodes list and end node list to generate the relationship matrix quickly. So the generating progress will also be faster than before.
So in general, how quick can it be? For example, several seconds, or I just have a detailed question. Yeah.
We just we don't do it. We don't we don't do it in practice, but the in our experiments, the test time can reduce from 6 hours to 2 or 3 hours.
Oh, okay. Thank you very much. 3 hours for the whole bunch of data set, is it?
Whole bunch of is sorry.
Okay. I get it.
All right. Thank you, Zay.
Okay, thank you.
So we have time for one final question. Changan, this is for you from Christian. Christian, if you want to unmute and speak, you can.
Yeah, sure. My question is, can you discuss the primary advantages of your approach over other approaches for learning source code representations? What kinds of relationships does it capture better than the other approaches? And can you give us some idea as to why it captures those more effectively than other approaches for learning representations?
Sorry, speak too fast. I
can go
can't follow you.
Yeah. What types of relationships does your learning approach capture better than other approaches for learning source code representations? And do you know why it captures those more effectively?
First, our input include 3 modalities, that is source code and AST and natural language. So our method can capture these 3 modality information, and our pre-training task can let the model learn the relationship between them. And our advantage is that first of all, the AST sequence is much shorter than before because we have shortened the SBT algorithm to half of their length is the original length. And second, our natural language can be retrieved from the source code only, where the other model or other methods use the function level documentation, which is not always available. So our method can leverage more pre-training data to learn the natural language information.
Okay.
Thank you.
So combining those into a single model turns out to be more effective than having them trained separately, and then because other models have other methods of doing this use bilingual models, right? So they have 2 different ways of representing that. So putting them together actually made your approach more effective. Is that correct?
Yes.
Okay.
Oh, thank you.
Thank you.
Thank you, Chandan, for your answer.
Yes, thank you.
All right, so we are running out of time. Sayu, maybe to time, Zeke, you can answer it offline maybe. So thank you all. Thank you to the presenters for the work which you shared, and for all the audience as well. Big round of applause to all of you, and thank you to Iris, who was our student volunteer. Thank you, Iris. You all the best for your work, and looking forward to see what you all do. Right.
Thanks, Prajesh.
Thank you.
Thank you, Prajesh.
Thank you very much.